Also from Feeding the Machine in collaboration with Options, your partner in digital acceleration. In this section, I'm going to talk about Mlflow, which is an open source platform for ML lifecycle. Mlflow brings us a solution for the experimentation, reproducibility, deployment, and central model registry. All of these models are totally decoupled from each other. For the experimentation part, you can do your regular work on ML or AI, and just with a few commands, you can record and save the metrics and models to create artifacts of your experiment. With the reproducibility, you can work and replay your experiment with a coworker or some area of DevOps or MLOps in a CI/CD process. The deployment part brings us the possibility to test in a carry deployment or A/B test, and more important, in a production environment, just with a few clicks in a CI/CD world. With the central model registry, you have the capacity to containerize your experiment or model and put in a repository of containers, just like Docker have. If you don't know about ops, this works like GitHub, which is a repository for your code, or in this case, your container. In this video, I'm going to talk about Mlflow tracking module, which, like I said, is the model for experimentation and development with the capacity to log your experiment. To begin, I will share my screen and start to detail with the first model of Mlflow tracking. I'm going to work in Anaconda Navigator, just for best visualization. But if you run this example in Python script, it's going to work just fine. For this example, we are going to see a standard ML training script in a Jupyter notebook. Starting with the classical imports, obviously you need to import Mlflow models, and in this case will be enough to start. In this line, we can create a variable with the naming of x or whatever you want. This is a variable to record the name or date for the experimentation. If you want to run this in a CI/CD development world or MLOps, this can be a parametric. So when we see the dashboard section of the experimentation, it's gonna be recognizable for all the past experiments. In here, we see some plots and some stages to analyze the dataset, some correlations, standardization, the classical ML job. There is no new in this. Now, in the important part, in the execution, we can see the run name argument in the section Mlflow *run. This is important because with this we initialize the experiment for Mlflow job. For the relevant information of this experiment, we need to record with the logParam function the hyperparameter involved in the experiment. So when we have results, all of this will be recorded. The difference with the traditional ML development is that we don't put this result in prints or some kind of output, like a plot graph comparing more than two metrics. We can use these parameters. The next part is to create an artifact that brings the capacity for recreate an experiment in another instance with the same libraries and conditions. In the terminal, we run the Mlflow UI command and visit the localhost web page. We can see the dashboard and all of the experiment running or ended. Last but not least, we can recognize and compare some experiment. This is the power of Mlflow tracking module. See the parameters, result, and hyperparametering, and share this with your coworker, so the development of these models can be visualized by all your organization. We can compare them. There is the same F1 metric, so there is no difference. But you can have the best model or the best fit in your experimentation. With this ends the part 1 of Mlflow posts and videos. Thank you for watching.